The risk of cardiovascular diseases. These are the collection of the heart and blood vessels illness that include the coronary heart disease, cerebrovascular disease, rheumatic heart disease, and other high blood pressure, high cholesterol, and smoking related all the significant risk factors for the heart disease. In 2019, they were found 523.2 million incidents for the cardiovascular diseases, which are in the rise from 26.6% in the rise from the 2010. This project is individual and based on the classification. Project summary. The purpose of this research was applied to the machine learning techniques to the estimate patient 10-year risk for the CHD, coronary heart disease, using data from the ongoing cardiovascular study from the Farmington, Massachusetts residents. The collection contained information on the almost 4,000 patients, features 15 features, each of which represent a possible risk factor for CHD. These characteristics include demographic, behavioral, and medical risk. Extensive pre-processing was undertaken to clean and alter the data in preparation for analysis. This includes the finding and eliminating the outliers using the IQR approach, as well as managing the missing values using mean mode median and the KNN imputation techniques. SKewNet continuous data were also modified using log and square root transformation to minimize the skewness and to improve the accuracy. To boost to reduce the multicollinearity, a variance inflation factor was used to feature in the selection, and a new feature term pulse pressure was generated to represent the link between the systolic and diastolic pressure. To verify all the features we are on the same scale, the data was scaled using a typical scalar approach. Overall, utilizing the data from the cardiovascular risk research, this effort revealed the ability of machine learning approach to protect and predict the CHD risk in patient. GitHub link is provided. Problem of this statement? The data comes from an ongoing cardiovascular study of the Farmington, Massachusetts citizens. The categorization purpose is to determine whether the patient will develop the CHD in the next 10 years or not. The dataset contains information about the patient. It has the 4,000 records with 15 qualities. Each characteristics is a possible risk factor. There are risks available that are the demographic, behavioral, and the medical in nature. So let's begin. We'll first import the data and mount to our drive. Then we'll import the libraries. All the main importation we have over there. Then we'll load the dataset in the data frame, read it. Dataset first view, it will show the first 5 rows and the last 5 rows by the head until dataset rows and columns count. So there are 3,390 number of rows and there are 16 columns. Dataset information. So all the 16 columns, there are no null values over there. Non-null values, and some of them have the data type of object or integer or float. Duplicate values, there are 0 duplicate values, missing and null values. Some column has the missing and null values also. So education, cigarette per day, BP meds, glucose are the most common factor. They have the missing values larger than others. Visualizing the missing values. Another way to do it is the heat map also. There are 16 features or the columns in total, 10 years CHD as the dependent variable column. There are 3,390 observations in the total datasets with no duplicate row. There are also blank columns: education, cigarette per day, blood pressure medications, total cholesterol, BMI, heart rate, and glucose. Understanding your variables. columns will describe in all the numeric values, variable descriptions of them, checking for the unique values in the dictionary and the printed. Next step is meta wrangling. So we'll create a copy for data set for doing the data wrangling. Then we'll rename the columns. Assuming the copy is our data frame right now. So the dependent variable is 10 years CST. Categorical variables are education, sex, smoking, BP medications, prevalent stroke, prevalent height, diabetes, 10 years CST. Continuous variable age, cellular per day, total cholesterol, systolic BP, diastolic BP, BMI, heart rate, and glucose. What all manipulations we have done? All the columns have been changed to the simplicity of usage. Next is the data visualization and storytelling. For the chart 1, we have distribution of 10 years CST, which shows the frequency and count of each category in the categorical variable. This shows the understanding of the balance or the imbalance in the distribution. According to the following, we figure out the 511 out of 3,390 are categorized positive for 10 years CSD, while the remaining are 2879 out of 3390 are classed as negative for the 10 years CSD. This data can assist healthcare firms in developing focused initiative. The data has no precise insight that implies negative growth, but failing to address the CHD indices. Second, distribution of plot age. Distribution of plot education, plot cigarettes per day, distribution plot for BP meds, distribution plot for prevalent stroke, distribution plot of prevalent height, distribution plot of diabetes, distribution plot of total cholesterol, distribution plot of systolic BP, diastolic BP. We have seen that there is outliers over there. Distribution plots of BMI, heart rate, and the glucose, and 10 year CHD. And there is sort of the graph that depicts the dataset distribution. There are more than the 100 observation. It can aid the detection of uncommon observation as the outliers and the gaps in the data. As a result, I utilize the histogram plot to determine the variable of distribution and was systematic or not. As a result, for each numerical variable in the supplied dataset, I utilized a box plot to examine the outliers and interquartile range values such as mean, median, maximum, and minimum. Histogram and box plot cannot provide us with the complete data information, just done to observe the distribution from the column data across the dataset and the outliers in the box plot for the various continuous column. Second is educational distribution, sex distribution, smoking distribution, BP meds, stroke, diabetes, tennis, CSTs. The size of the frequency of the different categories of grouping the data compared using the bar chart. Bar chart are excellent for comparing the data across the category and display for the vast quantity. It has the ability to have the positive business impact by giving the useful information for the decision maker. It understands the category different column aids in identification of the pattern. For the business, for example, can create a generate specific marketing campaigns and instructional program based on the target audience and education level. Fourth chart is 10 years CSG versus this is a Voyan chart. 10 years CSG versus cigarettes per day, CSD plus total cholesterol, CSD plus systolic BP, CSD plus diastolic BP, CSD plus BMI, CSD plus heart rate versus CSG versus glucose. The Voyant chart serves as a data visualization that amalgamates the elements from both of a box plot and the kernel density plot. The shape and width of the violin mirrors the data distribution, typically presenting the symmetrical form. The width of the violin at the different points come with the data density. The central box in the violin chart signifies the interquartile range IQR and encompasses the median value. Although the insight from the chart hold value, it's crucial to acknowledge that the impact on the business growth depends on the various factors. Realizing the actual business impact necessitates further analysis and the strategic implementation of these insights. Moreover, without this specific business context and objectives. Next chart, patient risk of CST by education, CST by sex, smoking, BP meds, prevalent stroke. Next is the correlation heat map. The correlation coefficient gauges the intensity in the direction of linear correlation connection between two variables. A correlation matrix is employed to condense the associations among a group of varieties, serving a crucial tool for data investigation and deciding which variables to incorporate into model. So the diastolic and systolic BP, additionally there is a correlation of 0.62 between the diabetes and glucose. The level of education does not apply a significant role in the acquisition of the CHD. So we can safely omit the education column. Here plot. The hypothesis testing. So let's perform the hypothesis testing. So the p-value is significantly lower than the 0.05, so we reject the null hypothesis. In order to examine the hypothesis, the education column does not influence the occurrence of CHD, so we conduct the chi-square test of independence. The chi-square test compares the observed frequency distribution of data in the contingency table, expected to be frequency distribution under the assumption of true null hypothesis. In summary, to utilize the chi-square test of independence term, from its widespread use and established reputation as a statistical test for examining the relationship between two categorical variables, it enabled me to draw a statistical reference regarding the relationship between the educational level and the CHD outcome in order to say. Feature engineering and data pre-processing, handling the missing values. BP meds will do the mode. In the cigarettes per day, we'll do the mean and median. Missing cigarette per day, so we'll have this data. It is obvious that the missing value of the cigarettes per day for all entry has the smoking column is as is. That is they smoke. Checking for any wrong entries where the patient is a smoker or not. There is no incorrect entry. Cholesterol, including the missing values also there. The glucose, we'll see the missing value, then we will mean median and mode for the glucose. The data exhibit a positive skewness with the value extending beyond the usual range. With the glucose column, there are 304 instances of missing data. Utilizing the mean and median for the filling the gaps might lead to notable inaccuracy. To address this issue, the KNN imputer method presents a viable option for substituting the missing data, replacing the string values of the binary column with 0 and 1. So the binary column which are the sex and is smoking. Changing data type, age, sex, smoking, cigarettes per day, vape nats, everything. We'll install pip install fancy impute using KNN imputer with k equal to 10. We'll extract the numeric column from imputation, then impute missing values using KNN, create a new data frame with imputed values, and combine the imputed numeric column with the non-numeric columns. Then we can calculate the mean median mode for the glucose column after the KNN imputation. So get the mean is 82, median is 70, and mode is 0 to 75. We employed the median and mode in the KNN imputation method to address the missing values in the dataset. The selection of this technique was based on their appropriateness, characteristic, and specific problem under the consideration. Specifically, median imputation was applied to the skewness. Numerical variables given its robustness as a measure of central tendency unaffected by outliers. Handling outliers, continuous variable, removing the outliers, drop the row with the NaN values, then reset the index, categorical encoding, extract the education column, then initialize the original encoder, cardinal encoder, fit and transform the education column, then display it. One hot encoding is used to encode the educational system. All the remaining categorical columns are binary, so no need to encode them. Feature and manipulation. First feature, remove multicollinearity by using the VIF technique. Variables in VIF. Then creating a new column, pulse pressure, and dropping the systolic dip and diastolic dip. Will display as a correlation matrix. Feature selection. Categorical variable is a list of categorical variable names. So we remove this smoking from the categorical variable list, then display it. So we have employed the variance inflection factor to address linearity, identify the high VIF values for systolic and diastolic pressure. Additionally, an observation was made regarding the smoking column, which merely donated yes or no for smoking. Similarly, the cigarettes per day column contained 0 for non-smoker and the respective numbers for cigarette day per day smokers. Ultimately, the crucial features include age, sex, cigarettes, BP meds, prevalent stroke, prevalent hypertension, diabetes, total cholesterol, BMI, heart rate, glucose, genealogy, education, and all. This column encompasses diverse information and covering the demographic and behavioral and current medical and historical medical data. Data transformation. Do you think we need to change the data? Yes. We'll calculate the skewness alongside the index axis for the continuous variable by using the lambda. Assuming the continuous variable square skewness value. Again, the data need to be transferred as it was skewed. We need to log transform and square root transform on the different continuous columns to reduce the skew of the data. Data scaling. Features continuous variable defining the x and y. In this we have different independent features of the different scales, so we have used the standard scaler method to scale our independent features into one scale. Dimension reduction, dimensionality reduction is not needed, so we have already reduced the number of features and only important features are left. Data splitting. Split the data into training and test set and display it. So we have, for model training we employed the train test split method. The dataset was divided into 80% for the training and 20% for the testing. Striking a suitable balance, the ratio ensures that the model is provided with a substantial amount of data for effective training, while still maintaining a sufficient quotient of 20% for evaluating the model performance on unseen data. The larger training set facilitates robust learning, and the smaller training set testing sets allow us to bridge the model generation to the new unseen data. Handling the imbalanced dataset. Says there is the imbalance and the number of positive cases are very low compared to the negative cases. So the target variable before the SM create an instance of SMOT ETM, fit and resample the training data. So visualizing the SMOT, we have implemented the SMOT combined with MOC links oversampling the techniques to address the imbalanced dataset. SMOT or synthetic minority oversampling technique create a synthetic sample for the minority classes, which enhance the class distribution balance. This involves selecting the instance in the proximity with the feature space, drawing a line between them. Mock links, the oversampling on the other hand eliminates the mock links, pair instance from the different classes that are very close in the feature space. Removing the instance helps clarify the decision between boundary classes. Machine learning model implementation will define a valued model function. For the precision test, we call this accuracy test and FN score. Logistic regression. Cross validation and hyperparameter training for the logistic regression. The selected hyperparameter optimization technique is grid search (CB). to optimal hyperparameter for a model. It is a widely adopted method for the hyperparameter tuning due to its simplicity in the implementation and effectiveness in the discovering the suitable hyperparameters. And then let's see the score. Logistic regression tuned one. It appears that the tuning did not improve the performance of the logistic regression. The precision, recall, accuracy, ROC, USC, and FN score on the test are the same for the both tuned and the untuned logistic regressions model. So the next model is decision tree. Then the cross validation hyperparameter tuning for that. It is a simple method. This method is widely embraced for hyperparameter tuning due to its simplicity and the implementation and the effectiveness in the identifying the suitable hyperparameters for the model. I have used the grid search in all the models. So let's see the score again. Decision tree and the decision tree tuned one. We have seen that the tuned decision tree model has the higher precision and F1 score on the test set compared to the untuned one. However, recall accuracy RUC score test decreasing slightly after the tuning. So tuned model is not overfitting like the untuned model. So we'll do the random forest for this. Then we'll do the hyperparameter tuning for the random forest. We have again applied the random search CV in this. This technique is widely used for adopting the hyperparameter tuning due to its efficiency. So we'll see the RF2 score. So it appears that the hyperparameter tuning improved performance for the random forest model on the test set. Tuned random forest model has higher precision, recall, accuracy, and FN score. It has the test set compared to the untuned random forest model. The ROC and AUC score on the test set also improved slightly after hyperparameter tuning. Next is super vector machine. Cross validation hyperparameter tuning again. Random search is widely favored for the efficiency compared for the exhaustive search method, such as grid search. This approach proves to be time-saving and computationally efficient while still identifying effectiveness of hyperparameter model. Let's see the SVM and SVM tune. It appears that the tuning improved the performance of the SVM model on the test set. The tuned SVM model has the higher recall accuracy and the F1 score on the test set compared to the untuned SVM model. However, the ROCAUC score on the test set decreased slightly after tuning. Next model is XGBoost, is extreme gradient boosting. Then we'll do the hyperparameter again for this. We have seen that in this, the performance of XGBoost model on the test set appears to be improved and the model has the higher precision, recall, accuracy and F1 score. But the ROCUC score on the test set also improved slightly after tuning it. Next is the naive bias. Then the cross validation and hyperparameter tuning again in the naive bias. Grid search is through the exploration technique to compensable combination of the hyperparameter defined in the hyperparameter grid. Neural network. Cross validation. It appears that the hyperparameter tuning improved the performance in the neural network model on the test set. Comparing the tuned neural network has the higher precision recall accuracy in F1 score. Test set has compared the neural network and the ROC score on the test set has also improved slightly after the training. Top for the scores for the model: precision, recall, accuracy, ROC, F1 score. Then we'll select the best model. So the best model of precision for the logistic regression, recall from the neural network tune, accuracy, neural network tune, ROC, decision tree, and F1 macro is neural network tune. Following through the assessment of the various machine learning models using the Farmington Heart Study dataset, the neural network tune has been designated the ultimate prediction model. This precision is rooted in the model commendable performance on our primary evaluation matrices with the CSD risk during our analysis. NN tuned consistently exhibit the highest recall score among the considered model. We will use the Shapley additive explanation, import SHAP. Assuming you have a feature from matrix X train and target variable Y train. Summarize the background, create an explainer object, compute the SHAP. So it's on 100%. Plot the summary, then this. This bar plot shows important feature and the mean SHAP values. It shows the average impact on the model output. Feature work optional. Conclusion in summary, this project effectively showcased the capacity of machine learning methodologies in accurately predicting the 10-year risk for the CST patients utilizing the data from the derived ongoing cardiovascular studies. Key takeaways are diligent data processing and transformation significantly enhance the machine learning model. The process feature selection provide crucial in identifying the most patient of predictive CSG risk. Employing techniques such as smooth, propellet MOOC, links, undersampling the standard and scalar scaling. It is the standouts that are noteworthy illustration of applying machine learning techniques to real-world challenges, showcasing their potential for the positive business impact. The project underscores the significance of material-based data interpretation and analysis in the realm of machine learning initiatives. By dedicating effort to cleaning and transforming data and selecting the pertinent features and opting for suitable models, can one achieve the accurate prediction and contribute the valuable insights to the decision making across the diverse domain. Thank you.